Writing repeating decimals is a pretty enjoyable topic once you get the hang of it, but it does take a little bit of work. So I recommend a few things. First, I would grab a notebook, a pencil, and then I'd also probably recommend putting this bad boy down. Right? We all know that you're going to lose the video game anyway, so why don't we get good at writing repeating decimals and, kind of put the games past us because even if I was in the lobby, I would still win, right? So without further ado, let's jump into the lesson. For the first 5 questions, we're going to be dealing with decimals that have every digit repeating behind the decimal point, and then we're going to branch off into some of those numbers being non-repeating behind the decimal point. So let's go ahead and jump into number one, where we have 0.4 repeating. And the biggest takeaway from this is to please take your time on these types of questions. They're not challenging, they are a little bit time consuming, but they do kind of have a pattern to them, right? The biggest mistake I see students do is that they don't take their time on these and they think they get really good at it and they rush through and then all of a sudden they get a D on an assignment, right? So again, take your time on it. There's no rush. Jot everything down that you see in your notebook and I promise that you'll be successful. So let's go ahead and start this off. The very first thing we want to do is come up with two equations. In this case, we're going to say that x is equal to whatever decimal that we're working with. So I'm going to write this equation on the side here. So we're going to say x is equal to the repeating decimal of 0.4 repeating. And I'm going to extend this 4 out a few place values. You're going to see why in a little bit. And now we need to come up with our second equation. And that is simply all dependent upon how many numbers are repeating. In this case, there's one number repeating, which is a 4. So whenever you have one number repeating, you want to take this first equation that we just made and multiply both sides of that equation by 10. So what is x times 10? Well, that's simply going to be 10x. So we have 10x equals. And then how do you multiply this repeating decimal by 10? It's very, very simple. All you want to do is move the decimal point one place value to the right. So you're essentially just multiplying by a power of 10, which is moving the decimal point once to the right. So now we have 4.4 repeating. And now that we have both of our equations, we now want to subtract them from each other. So we have 10x equals 4.4 repeating. And I'm just putting that dot, dot, dot at the end, just showcasing that the 4 goes on forever and ever, minus, and make sure you line up everything. Your variables are lined up, your equal signs are lined up, your place values, your decimal points, or else don't do all of this work and then literally mess up the subtraction out of everything, right? So we have the 0 in the ones place, we have a 4 in the tenths, hundredths, thousands, then again we have that dot, 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 and now we can go ahead and subtract them. So what is 10x minus x, right? There is a number in front of that x. It's simply just a 1. We just don't write it because 1 times anything is just going to be the same thing anyways. So that's why we simply just write x. So 10 minus 1 is 9x equals. And now notice we come up with these two equations purposely because the goal of this is to remove that repeating part so we can make a nice clean fraction. So 4 minus 4 goes away. 4 minus 4 goes away. 4 minus 4 goes away. And that repeating part is now completely gone out of the problem, right? Which is exactly what we want to make a fraction. Now we have 4 minus 0. Well, that's 4. And now we're left with 9x equals 4, which is a lot cleaner than what we had originally. Now we just want to get x by itself. It's currently being multiplied by 9, so we want to do the inverse or the opposite and divide both sides of this equation by 9. So let's divide both sides by 9. 9 divided by 9 is 1, or just x, equals, and since we want to leave this as a fraction, we're just going to leave it as 4/9. So our final answer for this is x is equal to 4/9. So 0.4 repeating as a fraction is 4/9. We can't simplify this at all, so this is our final answer. And now let's go ahead and move on to number 2. Just so I have enough space, I'm just going to make sure I get rid of all of this because some of these problems get a lot more involved compared to just one of these ones. Right, number 2, let's go ahead and start by making our equations. We have x equals this repeating decimal. So we have 0 point, notice how there's two numbers repeating now. So it's the 1, 2 over and over and over again. And now we need to come up with our second equation. Well, since there's two numbers repeating, we don't want to multiply both sides by 10, but this time around, we're going to multiply by 100 on both sides. So x times 100, well, that's just 100x equals. Well, how do I multiply this by 100? Don't move the decimal one place to the right, but two place values to the right. So we have once, twice, and now we're going to have 12.1212 dot dot dot. And now we can go ahead and subtract these. So we have 100x equals 12.1212 dot 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 minus x equals, again, lining up our variables, equal sign, decimal points. We have a 0 in the ones place, and then we have that 1, 2, 1, 2. And now we can go ahead and subtract these. 100 minus x, or 1x, is going to be 99x equals, and again, notice how when we make these equations, we can now cancel out that repeating part entirely. So the 2's go away, the 1's, the 2's, the 1's, and we're left with 12 minus 0, which is 12. And now we just want to get x by itself. So let's go ahead and move that over here. We have 99x equals 12. Again, we want to get x by itself, so let's divide both sides by 99 and do the opposite. 99 divided by 99 is just 1, so we're left with x equals 12 99ths. Now, this can be simplified a little bit. 12 and 99 are both divisible by 3. So if we go ahead and divide the top and bottom by 3, we end up getting x is equal to 4 33rds for number 2. So let's go ahead and erase this. That way we have space for the third one. This time around, it's 3 numbers repeating, but the process doesn't change at all. So let's go ahead and make our 2 equations. This is going to take up a little bit more space, so I'm just going to use as much space as possible just because I don't want it to interfere with my webcam at all. So we have x equals 0.375375 dot dot dot. And then we're going to multiply both sides of our equation by 1,000 this time for 3 numbers repeating. And then to multiply this repeating decimal by 1,000, we want to move it 3 place values to the right. So now we have 375.375,375. And now we can go ahead and subtract these. So we have 1,000x equals 375.375,375 dot 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 minus, again, lining up our variables, our equal signs, our decimal point. We have 0.375375, and now we can subtract it. 1,000 minus 1x is 999x equals, and then this should all cancel, the 5's, the 7's, the 3's, the 5's, the 7's, the 3's, and then we're left with 375 minus 0, which is 375. And now once again, let's go ahead and get x by itself. So let's go ahead and move that over here. I see I'm very, very close to the webcam. So we have 999x equals 375. And now let's go ahead and divide both sides by 999. And we're left with x equals 375 over 999, which can most definitely be simplified. You can divide the top and bottom by 3. So we are going to get 125 up top and 333 on the bottom. So fully simplified, getting rid of that repeating part entirely, we end up getting 125 over 333 for number 3, right? And now let's go ahead and move on to number 4. Now you're going to notice for number 4, this is the first time we see a number other than 0 in front of the decimal point. This is going to give you a headache if you don't do this step first. All I'm going to do is take this number 7 and completely forget about it for now. You just don't want to forget that it's there. So let's put that 7 up here and come back to it later. And we're going to pretend that this decimal that we're working with is really 0.2 repeating, very similar to the first one. And now let's go ahead and make our 2 equations once again. So we have x equals 0.2 repeating. We have one number repeating, so let's multiply both sides by 10, very similar to problem 1. We move the place value once to the right. We end up getting 2.222. And now let's go ahead and subtract this. So we get 10x equals 2.222 minus, again, lining everything up, our variables, our equal signs, our decimal points. And now we can subtract them. 10 minus 1x is 9x equals, notice again how everything cancels like it should. 2 minus 0 is 2, and now let's go ahead and divide both sides by 9. And we end up getting x is equal to 2/9, which can't be simplified, but don't forget that we have that 7 there. And all you need to do is tack it on to the front of the fraction, and our final answer is 7 and 2/9. This is the easiest way to go about it. You could keep the 7 in the problem. You might have to deal with an improper fraction, which takes a lot more work, right? Just removing that number from the decimal point makes life a lot easier, and it doesn't change what you're already doing to begin with, right? Now let's go ahead and move on to the very last one, which has all repeating digits behind the decimal point before we get into a little bit more trickier ones. Okay, so for number 5, make our two equations. Notice how we have a 13 out front. Let's go ahead and simply remove that for now. So I'm just going to keep that up here, and we're going to change this to a 0. We have x equals 0.7878 ... Two numbers are repeating, so we're going to multiply by 100 on both sides. So moving this two place values to the right, we get 78.7878 ... And now we can once again subtract these. So we have 100x equals 78.7878 minus, lining everything up, 0.7878. We have 100 minus 1, which is 99x equals, removing all of these once again, which is exactly what we want to see, 78 minus 0, 78, and now we can go ahead and get x by itself once again. So I'm just going to do it over here. We have 99x equals 78. Let's go ahead and get x by itself by dividing both sides by 99. And we end up getting x equals 78 over 99. The only problem is it still needs to be simplified a little bit, which we can do by dividing the top and bottom by 3, and we end up getting x is equal to 26 in the numerator and 33 in the denominator. The only thing that we don't want to forget, though, is that we originally had a 13 in front of our decimal point, so our final answer is really going to be 13 and 26/33 for number 5. So those are the 5 practice problems that I have for you when it comes to every number repeating after the decimal point. So let's go ahead and take a look at the next 5 that have non-repeating digits behind the decimal point. For these next 5 problems, notice that there's definitely digits that are non-repeating in this. However, it's not going to change the process that we've already been doing. It's just going to add one extra layer near the very end. So if we go ahead and jump into number 1, we have x equals our repeating decimal. So we have x equals 0.2, and notice how just the 7 is repeating, so that's the only thing I'm going to showcase that's repeating over and over again. We still have one number repeating, so we don't want to change that process. We're simply going to multiply both sides by 10 to form our second equation. So we have 10x equals, moving this one place value to the right, we get 2.7777 ... And now we want to go ahead and subtract our two equations. So we have 10x equals 2.7 repeating. Now, for these types of questions, this is even more important to line it up properly. We have our variables x lined up, our equal signs, our decimal points, and then we have the 0 in the ones place, the 2 in the tenths, and then we have 7s all after that. And now we can go ahead and subtract. 10x minus 1x is going to give us 9x equals, and you're going to notice that the repeating 7s are going to cancel, but we're not going to get a nice clean answer that we got in the last 5. We're going to have a decimal still, and you're going to see what we have to do, which is that extra layer I talked about a little bit ago. So 7 minus 2 is 5. The decimal point is still included in this, and then 2 minus 0 is 2. And now we can go ahead and divide both sides by 9 to get x by itself. So divide by 9, divide by 9, the 9's cancel, and we're left with x equals 2 5/10 over 9, which obviously isn't the fraction that we want because we have a decimal up top. Well, how do I move that decimal point one place value to the right? We already did it in the previous questions. All we have to do is multiply by 10. But if we multiply by 10 in the numerator, we also want to do it in the denominator. So let's go ahead and get the fraction that we want. So let's go ahead and multiply by 10 here and 10 in the denominator. And we end up getting x equals 2.5 times 10, well, moving it one place value to the right would give us 25 over, well, 9 times 10 is just 90, and now we got a nice clean fraction that we were looking for. The only thing is that we do have to simplify this a little bit, and we can do that by dividing the top and bottom by 5 here. And we end up getting x equals 5/18 for number 1, right? So a little bit of work. Notice how what you do with the decimal and the numerator, all you have to do is multiply by how many place values you want to move that decimal point. All I want to do is move it once to the right, so I just multiply by 10, right? So let's go ahead and get rid of all of this. And let's go ahead and head to number 2. So we have x equals 0.49, and the 1 is just repeating. We have 10x because only one number is repeating, so we're only going to move this decimal point one place value to the right. And now we can subtract them. We have 10x equals 4.9111 minus x equals 0.4911 dot dot dot, and now we can go ahead and subtract these. So we get 10 minus 1, which is 9x, equals, the 1's cancel, the 1's cancel, 1 minus 9 you can't do, so you have to borrow. This becomes an 8, and now we have 11, so 11 minus 9 is going to be a 2. 8 minus 4 is 4. We have the decimal point, and then 4 minus 0 is 4, right? And then once again, let's get x by itself. So let's go ahead and divide both sides by 9. 9 divided by 9 is just 1, so we're going to be left with x equals 4.42 over 9. And notice this time around, we have to move this decimal point 2 place values to the right. So we don't want to multiply by 10, but let's go ahead and multiply the top and bottom by 100 this time. So times 100 times 100, and we're going to be left with x equals 442 over 900. And once again, you can simplify this. The top and bottom are both divisible by 2. So 442 divided by 2 is going to give us 221 over 450 in our denominator. So that is the second one done. Again, let's go ahead and erase this and head to number 3. Right, for number 3, once again, same exact process. Notice how it's taking me a ton of space. So I'm just kind of really at this point writing wherever. That way I have enough space. That's why I told you to write in a notebook so you don't run out of room. I just don't want to cut into the webcam and all. I guess I could make the webcam smaller, but I don't think it's going to make a difference with these math problems, right? It just takes up a lot of room, right? So let's go ahead and make our two equations. We have x equals 0.946. We have two numbers repeating, so we have the 4, 6 over and over again. We want to multiply this time around by 100 because we have two numbers repeating, which means we're going to move this decimal point 2 place values to the right. So we have 94.6464 dot dot dot, and then we can go ahead and subtract these. So 100x equals 94.6464 minus, line up our variable, equal signs, decimal point. We have a 0, 9, 464, and then we can subtract them. 100 minus 1 is going to give us 99x equals, the 4's cancel, the 6's cancel, the 4's cancel. Our decimal point is going to be there. 6 minus 9 you can't do, so let's borrow. We get a 3. This is 16. 16 minus 9 is 7. That's going to be behind that decimal point. And then we're left with a 93 out front. And then let's go ahead and divide both sides by 99. Right? And now we have x equals 93.7 over 99. This time around, we just want to move the decimal point one place value to the right, so don't multiply by 100, but multiply by 10 on the top and bottom. And we are left with x equals 937 over 990. And this is completely simplified. You can't divide the top and bottom by anything. So this is our final answer for number 3. Right, and now we're down to 2 more. So let's go ahead and get rid of this once again and move on to number 4. Just like we did in the previous questions, notice how there's a number in front of the decimal point. We're going to take this 13 and simply remove it for now and come back to it later. So I'm just going to keep it up here as a reminder. That way I don't forget. Even though sometimes I've written this reminder and I literally forget. So please make sure that you don't forget it. Star it, box it in 5,000 times so it's very noticeable. That way you don't mess it up. So let's scribble out that 13 and make it a 0. And make our 2 equations. X equals 0.47878 with the 78 repeating. We're going to multiply by 100 on both sides because there's 2 numbers repeating over and over again. We're going to move the decimal point 2 place values to the right, so we get 47.878, and now we can subtract them. So we have 100x equals 47.878 minus x equals 0.478. We get 100 minus 1x is 99x equals, the 8's cancel, the 7's cancel, and we're left with 47.4 on the right side. So now if we just move up here, we have 99x equals 47.4. And now let's get x by itself by dividing both sides by 99. These cancel. We get x equals 47.4 over 99. We want to get rid of that decimal point by moving it once to the right. So we do that by multiplying the top and bottom by 10. And we end up getting x is equal to 474 over 990, which can be simplified if you divide the top and bottom by 6. So we end up getting x is equal to 79 over 165. The only thing is that we do not want to forget this 13. So all we're going to do is tack it on to the front of our fraction, and our final answer is 13 and 79 over 165. And then we are on to our very last one. So let's go ahead and remove all of this in one go, hopefully, without missing a dot. Looks like I missed a couple. Okay, and I think we're good for the very last one. So again, I'm just going to write this as far away as possible because there's just so much to write for this. So I am going to remove this 6 and not forget about it. So I'm just going to underline it a few times up here and then change this to a 0. So we have x equals 0.302, and the 2 is the only thing repeating. So we're going to multiply both sides by 10 for our second equation, moving this once to the right. So we get 3.02 repeating. And now we can go ahead and subtract these. So we have 10x equals 3.02 repeating, minus lining everything up once again. We have a 0. We have 302 ... 10 minus 1 is going to give us 9x equals, the 2's are going to cancel. We have 2 minus 0 is 2, 0 minus 3 you can't do, so we have to borrow. This is a 10, 10 minus 3 is 7. Decimal comes down, 2 minus 0 is 2, and then divide both sides by 9. And we now have x equals 2.72 over 9. We have to move this decimal point 2 places to the right, so we're going to multiply the top and bottom by 100. That way we can get a nice clean number in our numerator. So now we have x is equal to 272 over 900. And now you can divide the top and bottom by 4. And when we do that, we are going to get 68 over 225. And then the only thing that we don't want to forget is that 6 goes out in front of the fraction. So now we get 6 and 68 over 225 for number 5. So those are problems where you might have a digit or two that are non-repeating in the decimal. So that's kind of how you go about doing that. Notice how, again, there's just a pattern to it. You get a decimal up top, what do you multiply by to move it to the right? 10, 100, right? Now, I have a few questions I want you to try on your own. So consider this the practice session. This is where I simply want you to pause the video. I want you to try these questions out completely on your own. And then once you think you're ready to go, press play. And all I'm going to do is jot down the answers. So go ahead and pause the video here, and let's see if you can go 5 for 5 in a little bit. So I'm assuming at this point you have finished these 5 problems, and now we are simply going to check your answers. So I just wrote them down on this. So I just wrote them down on this notebook, right? For the first one, 0.5 repeating, you should have gotten 5/9. For number 2, you should have gotten 8 and 176 over 999. For number 3, you should have had 7/18. For number 4, 427 over 990. And finally, number 5, 7 and 617 900ths. Right? If you went 5 for 5, let me know in the comments that you went 5 for 5. That way I know if this video helped you out or not. And if it did, please leave a like. Comment anything else you want to see in the future. And don't forget to subscribe. Turn that bell on for notifications. I appreciate you guys taking the time to watch. I hope it helps you out a lot and you do well on your next quiz. We'll see you in the next video.